Happy holidays to everyone out there. This is Ned Bellavance, Ned1313 on the Twitter, and this is my contribution to the Azure Advent Calendar. I'm going to be talking about AKS with pod identity. Let's dig in. So, what are we going to do? We're going to stand up an Azure Kubernetes Service cluster, and we're going to create a user assigned managed identity in Azure Active Directory. And finally, we're going to create an Azure Key Vault, and we're going to use that managed identity assigned to a pod in AKS to access a secret stored in the Azure Key Vault. Pretty cool stuff. If you'd like to follow along, I am going to be putting the repository with the examples up on my GitHub account. It's Ned1313, super easy to find. Locally, you're going to need Terraform installed. You're also going to need the Azure CLI for authentication and running some commands. And you'll also need kubectl. If you don't want to install all those things locally, you can always just run this all from the Azure Cloud Shell because it has all these tools pre-installed. Pretty easy there. All right, let's get right into it. The first thing we need to do is deploy our environment, and the tool we're going to use for that is Terraform. Let's jump over to Visual Studio Code and look at the configuration a little bit. Okay, Visual Studio Code, here we are. I've got the files, and in the folder deploy AKS, I've got a number of different Terraform files which take care of deploying the environment we're going to use to test out the pod identity functionality. So I'm not going to go super deep into the configurations, but just to give you an idea of what we're deploying here, let's open up the main.tf file. We're defining some variables here with default values for the location. I'm using the East US 2 location because it supports availability zones in that region. For the agent size, I'm going super small, standard B2S agent size. So the worker nodes in our AKS cluster are going to be tiny, which is fine. They don't need to do a whole lot. For our prefix, I'm using that for some naming things within the context of the Terraform configuration. I've gone with the default of Advent because this is, after all, Azure Advent. Then we're invoking some providers. We're using the Azure RM provider and the Azure AD provider. All the authentication is going to be through the Azure CLI, so we don't need to provide authentication information there. Scrolling down, we need to create a password for a service principal that will be used for that AKS cluster. So we have to create a random password for that. We're also going to create an Azure AD application and service principal. So those are going to be associated with the AKS cluster, and then create that service principal password. Once we have all that, scrolling down some more, we have to create our resource group for our Kubernetes cluster. We're going to call that Advent-AKS. Within the Kubernetes cluster, we're defining some information here. The cluster itself is going to be Advent-AKS. And the Kubernetes version is going to be whatever the latest version that's available on AKS. We're going to just go, right up to the bleeding edge with that. It's going to be 1.15 something. We're going to define a single node pool here called default, and I'm going to put 3 nodes in that node pool of the VM size standard B2S, and stretch those worker nodes across 3 availability zones using virtual machine scale sets. So that's pretty cool. That's a relatively new feature that's been introduced in GA for AKS, the ability to have your worker nodes span availability zones. And of course, that requires virtual machine scale sets for that to work properly. Scrolling down some more, for the network profile, we're just using KubeNet standard. I don't need to use any advanced networking features here, at least not for this particular demo. And under our service principal, we're just giving it the service principal that we just created and the password for that service principal. So that's the service principal that the cluster will use to interact with other Azure services. Scrolling down a little bit more, we're going to create a user assigned identity, and that's going to become very important shortly, but I'm not going to dive too much into what that user assigned identity is. Basically, all you need to know is it's called AKS-user-MSI. Okay, that's everything that's in the main.tf file. We're also creating a key vault as part of this deployment, so let's open that up real quick. For the key vault, we're creating a separate resource group for the key vault called advent-kv. We have to create a globally unique name for this key vault, so we're going to generate a random ID, and then the name is going to be advent plus whatever that random ID is, so we know it's globally unique, since the URI for key vault has to be unique from all the other key vaults out there in Azure. The SKU is going to be standard. We don't need premium. We don't need an HSM. We're going to create two access policies here. Now, the first one is for that user principal in the main file. So that last one that we created, that user assigned identity, that's managed service identity. We're going to grant that permissions on this key vault to get and list secrets within the key vault. That's important for later. The second thing is under access policies, we're going to give the user that we're logged in as permissions to get, set, list, and delete secrets. So we'll be able to actually create a secret within this key vault. And the reason we have to configure that access policy is because the next resource that's being created is a key vault secret. The name of the secret is going to be everything. The value is 42. If you understand that, good for you. And we're putting it in that key vault. So now we have an AKS cluster, we have a user assigned identity, and we have a key vault with a secret in it. And we want to tie those things together. The last thing we're going to do is generate some YAML files based off a template, and those will be used with the pod identity deployment process. So if we go into template files, there we go. We're creating a template file called AAD pod identity and populating it with information about that user assigned identity that we created earlier. And then we're creating a second file called AAD pod identity binding. And for that, all we need to do is supply the name of the user defined MSI, which we're calling AKS-user-MSI. And then we're using the local file resource to create the YAML based off of both of those templates. Okay, so that's the entire configuration for Terraform. How do we go ahead and deploy this? Well, it's pretty standard operating procedure. Let me open up the terminal here, and the first thing I need to do is log into Azure using the Azure CLI. So the first thing I'm going to do is run AZ login. And because my account is a guest account that's used in multiple tenants, I have to specify which tenant I'm using. You probably won't have to do this, but I'll go ahead and run that. And it now will launch a separate browser window and prompt me to click which user I want to sign in as. So I clicked on it in the other window, and now it's finished my login process. The next thing I need to do is select which subscription I want to use. So I'll do AZ account, set, subscription, and the subscription I want to use is MAS, but choose whatever subscription you're going to use if you're following along. Okay, so now we're logged in with the correct subscription and the correct account. Now Terraform can use that cached login from the Azure CLI for the credentials when it's performing its work. So first, let's initialize Terraform by doing Terraform init, and this will download all the provider plugins that we're using within the context of this Terraform configuration. All right, successfully initialized. The next thing to do is to run Terraform plan, and we're going to output that plan to aks.tf plan. Always a good idea to output your plan to a file so it knows that it's deploying exactly what you want when you get to the apply stage. So this is going to go ahead and look at what the current state of the deployment is and determine what resources it needs to create, alter, or destroy in order to make the current state match what the desired state is in the configuration files. All right, so it's going to add 13 new things to our Azure environment as defined by the configuration files that we just looked at. So now we can go ahead and run Terraform apply aks.tf plan. Go ahead and copy that and paste it here. And now it'll go out and make our plan a reality. It's a Christmas miracle. So that's going to take a little while to deploy, especially the AKS cluster. I've seen that take up to 20 minutes to deploy. So while we're waiting for that, let's jump back to the presentation and talk a little bit about pod identity and what we're actually doing with that. Pod identity leverages managed identities within Microsoft Azure. Managed identities used to be called managed service identities, which is where the MSI abbreviation comes from. It's recently been renamed to managed identities for whatever reason. Microsoft does weird things sometimes. There's two basic kinds. There's system or user. System MSIs are assigned to a particular system when it's created and destroyed when that system is destroyed. So if you create a virtual machine with a system assigned identity, when that virtual machine is destroyed, that identity is bye-bye, and that identity can only be used by that virtual machine. Whereas if you create a user-defined managed identity, that lives outside of a particular system, and so you can assign multiple virtual machines, say a VM scale set, to all use the same user-assigned identity to access resources within Microsoft Azure. The credentials for either of those managed service identities, as implied by the name, are managed by Microsoft. So Microsoft is in charge of managing those credentials. The way that a system gets those credentials is by using the Azure Instance Metadata Service, or IMDS, which is available at the 169.254.169.254 metadata address of that system running within Azure. So it just has to send a request to that URL asking for an access token for whatever service it wants to use, and the instance metadata service will authenticate using that user or system managed identity and retrieve a token for that system to use. So that's basically what we're leveraging here. Pod identity is a way for pods within a Kubernetes cluster, within an AKS cluster in this case, to use either a service principal or a user managed identity to access resources within Azure, say Key Vault, for instance. And the pod identity is actually two different sets of containers and a custom resource definition as well as a service. The two containers are the MIC and the NMI. The MIC is the Managed Identity Controller. Now, what that does is, let's say we have a node, and on that node, we have spun up a pod. That pod has been enabled to use pod identity. So when that pod is spun up, the MIC will note that the pod is enabled, and it will assign the service principal or the user managed identity to the node that's running that pod. The NMI is the node managed identity pod. That's responsible for proxying requests for access tokens from the instance metadata service. So when that pod makes a call to the metadata service saying, hey, I need an access token to get to something, say maybe Key Vault, the NMI intercepts that and then on behalf of the node sends that to the IMDS, which then grants the access token, assuming it has access, and feeds that information back to the pod successfully. So that is how the pod gets an access token to reach out and talk to one of the services within Microsoft Azure. So the next step in our process is to deploy the pod identity service on AKS, and then we're also going to deploy a secret app that will be able to retrieve the secret that we've placed in the Azure Key Vault. So let's go back to VS Code. Okay, our deployment has completed successfully. It actually failed the first time, so I reran it, but I didn't want you to wade through all that. Sometimes the service principal that gets created for the Kubernetes cluster doesn't show as available yet when it tries to create that cluster, and so it fails saying, I can't find the service principal. But if you just rerun the plan and apply, it'll find it the second time around and successfully deploy the rest of the infrastructure. So we're all set. We've got all the resources that we wanted created. Now, the next step is to create the pod identity information. So I have a script over here called AAD pod identity. Let's go ahead and open that. The first thing we need to do is get our AKS context because we're going to be deploying things to this Kubernetes cluster. So we're going to run AZ AKS get credentials and pass it the resource group name that the AKS cluster is in and the name of that cluster. In this case, they're both advent-AKS. So I'm going to go ahead and grab that command and paste it down here. And now it has merged advent-AKS as my current context within my Kubernetes configuration. So all commands I'm running using kubectl will be at this particular cluster. The first thing we're going to do is deploy the managed identity controller, the MIC, and the node managed identity. And there's a deployment YAML already on GitHub within the project for pod identity. So that's all we're really going to do here is run kube apply-f, which says deploy what's in this file. And we're going to grab the file from the GitHub AAD pod identity repository, and it's called deployment-rback.yaml. Let's go ahead and grab this whole command. We'll copy it and paste it down here. And this should deploy relatively quickly. There we go. It creates a service account for the NMI. It creates some custom resource definitions, a cluster role and cluster role binding, a daemon set, another service account, another cluster role and another cluster role binding, and finally a deployment for the MIC. So now we have a deployment for the NMI and a deployment for the MIC. If we run kubectl get pods, it will show us we've got 2 MIC pods and 3 NMI pods running. So that's all the pods we're going to need to run the pod identity service. But there are 2 more components here, and that's the 2 YAML files that were created during the Terraform configuration, the AAD pod identity and AAD pod identity binding. Let's take a look at what's in those files. So I'll expand out the YAML files. We'll look at pod identity first. This configuration is of kind Azure Identity because we've now deployed that custom resource definition. And we're basically specifying the user assigned identity we created through the Terraform configuration that has the client ID that's shown here and the resource ID that's shown here. The type 0 indicates that we're using a user assigned MSI and not a service principal directly. So we're going to deploy this. This just creates that Azure identity. And then the second file, if we open that, creates the Azure identity binding. And this has 2 important things. One, it identifies the name of the Azure identity we're using, AKS-user-MSI, but it also has a selector field. And this is how pods let the MIC know that they have been enabled to use this identity. If they have a label within their configuration that has the value advent-msi-example, then that will tell the MIC they're enabled to use this particular identity. So this is the binding between the user assigned MSI and the actual pods that want to use it through a label. So we're going to run these 2. We'll go over to our script and just copy those 2 deployments. Here we go. We created the identity and we've created the binding. So that is all set. Now we can deploy an application that's going to take advantage of those. So I have an application in a separate folder called Secrets app. We can go ahead and expand that. And there's a deployment YAML in here. Let's open that just so I can point out the label selector. So looking down in metadata labels, there's a label called AAD pod ID binding. And we've set that to Advent MSI example. Further down within the template metadata labels, we have the same label key value pair again. So basically, this deployment is going to have that label associated with it. So any pods that are created, we're creating a pod here that has the container AKS-ID-app. When we create that, the MIC is going to say, oh, okay, you are enabled for this particular ID. I'm going to go to the node that's running that pod and assign it that user assigned MSI as well. So that's all the MIC needs to do. So let's go back to the shell script and actually need to change directories here. So I'll go up 1 and go into that secret app where I have that deployment YAML. And I'll grab this command here and paste it down here. And there we go. It's created that deployment as well as a service using a load balancer so that it has an externally accessible IP. If we do kubectl get pods, we can see there's now one pod called Advent, and it's in the container creating stage. If we do get service, we can see there's an Advent-service, and that already has an external IP associated. So once the container is done spinning up, we can go to that external IP and see web page that is served up by this application. In case you're wondering, the application is a Flash application that runs Python, and I actually have the source files in the app folder here. So if you want to pick apart what's going on within the application, how it calls and invokes asking for the token and then asking for the secret out of the key vault, you can look at that there. That's probably a little beyond what we want to do today. Let's go ahead and check the status of the pods again. Okay, it's still in container creating, so we can do get pods-w, and that will set up a wait, and anytime a particular pod from this query is updated, it will print out the status of that pod. So we're just basically waiting for this to go from container creating to running. Okay, it's changed from container creating to running. So let's go ahead and grab that public IP address and we'll bounce over to the portal and open up a new tab here. And all it asks for within the application is the name of the key vault and the secret that's stored in that key vault. So let's get the key vault name by going over here and refreshing our view of the key vaults in the subscription. There's the Advent key vault with its unique ID appended on there. And I'm going to go ahead and copy that because I'm not going to be able to type that correctly and paste it in here. And then the secret name was everything. Now I'm going to go ahead and click get my secret and wah, wah, wah. Surprise, the Grinch is here and he's having a little trouble with this Christmas thing. It turns out that the current library for Python that is used by Azure Identity has a bug in it and it doesn't return the right token type when you invoke it. I kind of knew this was going to happen, so I have a plan B. If we go back to our script, because this pod has been enabled to use that managed identity, what we can do is instantiate a shell session within the pod and run some commands from within the pod to verify that it would work if the bug wasn't in that Python library. So I'm going to run kubectl exec-it to create an interactive session with this pod. And I'll just do sh, that's the shell I want to run. There we go. Okay, I'm now connected into that pod. If I do an ls, we can see this is the app directory where it's running the Python web app. So what we can do is directly send a request to the metadata service. So this first line up here is using curl to send a request to the metadata service. And what we're going to request here is that we want to access something that's in the resource vault.azure.net. So I need a token that's associated with the Vault service. So we'll go ahead and grab that, copy it, paste it down here. And then out of that response will be an access token within the JSON payload. So what we want to do is just use Python to extract that access token from the JSON payload. So we'll go ahead and run this command. Now we have the access token. If we do echo, we get this big long string of an access token. And then the last thing we can do is request the secret from the key vault. So I'm going to need to grab that key vault name again, copy it from here, go back here, and just replace the vault name with the actual key vault name. And what we're doing is using curl to make a request for the secret everything. And within the header, we're adding an authorization that has that access token associated with it. So let's go ahead and copy that. We'll paste it down here. And we get back a response that has the value 42. So we were able to successfully get an access token from within the context of this pod, and then use that access token to retrieve a secret from a key vault. So that's pretty cool. The pod identity thing works. And if the bug wasn't there with the current Python library, that web page would have worked as well. And who knows, by the time you try this out, it might be working because I've already put in a bug report for it. So that will do it for my demonstration for the Azure Advent Calendar. Thank you so much for watching. If you want to reach out to me, you can find me on Twitter. It's Ned1313 or nedinthecloud.com. Thank you to Richard Hooper and Gregor Sutti, I hope I'm saying your name right, for putting this together. I think it's an absolutely amazing event, and I highly encourage you to watch all the demonstrations that are part of the Azure Advent Calendar. Thank you, everyone, and happy holidays.